Bonjour, welcome to Wahsa Citizen Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I'm the teacher, Bronwyn Slate. If you would like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You're always welcome to join me live with the Zoom link. It is available both from me and also your DEC. Our classes are scheduled from Monday through Thursday, 2 to 3 in the afternoon, and we are in our 5th week of our 9-week course. So a reminder that the support questions are what are practice problems, so you are not submitting these for marking. They are just things for you to get comfortable with these concepts. You can decide how many and which ones to do. You know what you need best. If you need to do them all, that's great. There's not a ton of them. If you're really feeling confident with yourself and you want to skip them, you do you. The answers are in the back of the booklet, so please check your work just to make sure that you are on the right track. And then if you have any questions, you can let me know. The key questions, the ones with the key icon, are the ones to submit for marking. So please do all of these questions, so showing all of your work, your steps, and your thinking. This way, I have the best chance of understanding what it is that you understand. And if you are struggling with anything, why you are maybe struggling, what mistakes you maybe are making. So the more information you give me, the better. So how do you actually submit your work? Well, there's 3 methods. The first is to send your work electronically and either taking pictures if that's what you need to do or scanning it. If you have a device, you can scan using that, using an app. So if you have an Apple device, the Notes app has a scan function. And if you have an Android device, the Google Drive app has a scan function. These are free apps, and the scan function is pretty easy, pretty much point and click. If you are not sure how to do this and would like to learn, feel free to reach out and I can walk you through it. Or you can go check out my YouTube channel, where there are tech tutorials that walk you through how you actually can scan with these apps. Then once you have your file, then you can send it either through email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca, or you can send it through Facebook Messenger to bslatewahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our 74 Front Street location. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me on social media, both my Facebook and my YouTube channel are under the name bslatewahsa. All of our radio Zoom classes are recorded, and I upload them shortly after airing to my YouTube channel and then also share them on Facebook. You can find all of our videos under a playlist called MBF3C, which is our course code. There's also short videos that explain common errors and confusing concepts, which can be useful to go and check those out if you're struggling with something. Math is a really visual subject, so I strongly encourage you to access the videos. This is how you're going to get the full experience and hopefully understand to the best of your ability. If you cannot join me live through Zoom and are unable to access the YouTube videos, please let me know and I'm happy to send you a copy of the videos so you still get the full experience. If you have any questions or concerns, please reach out and connect with me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is bslatewahsa. Calling me at the office is great, 807-737-1488. My extension is 2209. You can also call us toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m. All right, today is a Throwback Thursday lesson. So we are going to be reviewing everything since the beginning of the course, but we're going to focus specifically on lessons 8 through 12 today. So just to reflect upon why we are reviewing already, though we are halfway through the course, over halfway through the course now, that it makes sense to review so that we are getting closer and closer to the end. But also, research done by Hermann Ebbinghaus in 1885 shows us that we do not retain very much information for long periods of time without repeated exposure. So we have this graph that shows us the forgetting curve, and we can see that after one day, we've already lost about 20% of what we learned in the past 24 hours or so. So after about a week of this progress, we've lost about 60%. We've only retained about 40% of what we learned a week ago. So it's really, really beneficial to revisit topics, because not only do we remember more because we're revisiting it, we also don't forget it as quickly. We retain it for longer periods of time, as you can see on the second graph, which shows that if we revisit something, we go back to 100%, and then it takes us longer to forget that same material. So this is why we review frequently. All right, first let's activate your brain and do some mental math. I don't believe in mad math minutes. They are generally stressful and not beneficial for students. So instead, I believe in developing strategies that build on comfort and your confidence in your skills and your knowledge of numbers. So that's what we do in my class. So today's question is 267 divided by 14. And we're going to use the concept of partial quotients. So this, again, is one of those strategies that is not necessarily super easy to do in your head, but you still can try to do it in your head, but writing it down is totally fine. It's not just about mental math. So how I write this down is I still do division. I put my 267 inside my long division symbol and 41 on the outside, because that's what I'm dividing into. But how I do my division now is I think about the whole numbers. So I think about how many groups of 41 can fit into 267. So I like to start off with really friendly numbers. Can 10 groups of 41 fit into 267? Well, 10 groups would be 410. So no, that will not work. But maybe 5 groups can. Well, if 10 groups is 410, then 5 groups is going to be 205. So that does fit. I do have enough things. So if I have 5 groups, that's 205 things that I've dealt with. So that means that I've already dealt with those, and I can subtract to figure out how many more I have left. Well, I only have 62 things left to deal with. So 41 is only going to fit in that one time. So only one group is going to fit in. So that means I'm left with 21. Well, 21 is about half. So this is about half a group. So I can see that 67 is going to be about 6.5 when divided by 41. So even you can do decimals. This is not exact, but this is, if I were going to round it, it would be 6.5 if I were using a calculator. So this is just, instead of trying to do the long division algorithm and remembering all the rules, thinking about it logically can be really quite helpful. All right, so what are our highlights from the course so far? Sorry, it seems as though my done something odd with my design. So I'm just going to see if I can get it to go away because all of my slides are funny looking. Can I don't want that. I don't know. There we go. Just hit a button in the wrong way. Okay, sorry about that. All right, my highlights from Unit 1 are Lesson 1, we talked about transformations of quadratics. So you were using the quadratic general form, which is y equals a times x minus h to the exponent 2 plus k, where a tells us the opening direction of the parabola, h tells us the horizontal shift of the parabola, and k tells us the vertical shift of the parabola. So how we can get every kind of parabola using those 3 parts. Then in lesson 2, we looked at polynomials and factoring. So a reminder that expanding means that we multiply according to the distributive law. So everything that is outside the brackets must be multiplied by everything that is inside the brackets. And if we have binomials and we're multiplying binomials, so 2 terms times 2 terms, that we need to use one of our strategies like FOIL or the box method or using algebra tiles in order to make sure we are multiplying everything by everything. Then factoring is when we're going backwards. So factoring means to find the 2 binomials that result in the trinomial product. So we have kind of like the answer and we're trying to figure out the question. And in order to do that, we need to figure out 2 numbers that multiply to be the constant term, which is usually in the 3rd place, and add to be the coefficient of the x term, which is usually in the middle. Then in lesson 3, we looked at solving and graphing quadratics. So when we say solving a quadratic, this means that what are the values of x that result in y equaling 0? So when does the zeros or the x-intercepts happen? When does our parabola cross our x-axis is what we're looking for when we're solving a quadratic. And then we looked at exponent laws, and we had 5 different laws that we focused on. So the multiplication exponent law, which is when you have the same base that are multiplying by each other, that you add your exponents. When you have the division law, when you have the same base, you subtract your exponents when you're dividing. If you have a power of a power, so you have a base with an exponent and all of that is raised to another exponent, then you're going to be multiplying the exponents. We discovered why the 0 exponent law works. So anything to the exponent 0 is always going to equal 1. And then we looked at negative exponents, which can be really tricky. And this is the reciprocal of the base with positive exponent. So when you have a negative exponent, you flip your base. So it's generally 1 over your base with your positive exponent. The number is still there, you just don't have a negative anymore. And then lesson 5 was simple exponential equations. So we looked at how exponential growth or decay is very, very fast change. Growth is when you're increasing, decay is when you're decreasing. And the function for that is y equals capital A times b to the exponent x. As always, this is just a quick review, and if you need more coverage on this information, you go back to those lessons. They're all available on YouTube. All right, so then looking at Unit 2, Lesson 6 was simple interest in linear growth. So the pattern increases or decreases at a constant rate when we're looking at simple interest. The formula that we used is I equals PRT, principal times rate times time. And if we're looking for the total accumulated amount of money that we have earned or need to pay, which is, so your A is equal to your principal plus your interest. Then in lesson 7, we looked at compound interest and exponential growth. So for this case, compound interest, the pattern increases or decreases at a constant ratio. So we're multiplying by the same amount each time. Our formula is A equals P times 1 plus R over N to the exponent NT. And in this case, you're finding the total accumulated amount. So if you're looking for just the interest, you have to subtract the principal from the accumulated amount. All right, and then we are now going to dive into looking a little bit closer to the newer lessons from last week and this week. So lesson 8, we dove into the compound interest formula further. So we figured out how to dissect a compound interest problem. So we realized that we always need to have compound in the problem. This is how we know that we are compounding. We then must identify what information is given and what we are being asked to find. So this is how we set ourselves up for success, is by figuring out what we know and what we need to know. Then we learned how to find the principal, which meant that we just needed to rearrange the formula using algebra to isolate for P. When we were finding the interest rate, the R, we needed to rearrange the formula, but also we needed to use the nth root to isolate for R. So we talked about how the square root is the inverse function of a squared. So the nth root is the opposite of anything to any exponent. So if it's a 20th exponent is a 100 exponent, you would take the 20th root, or you take a 100th root. It depends on your situation, but it's the inverse. Then we looked at finding the time length, T, which is tricky. We don't have all the tools that we need to do it exactly, but we were able to use guess and check to force the bases to be the same or as close as possible. And that meant that we were able to set the bases. If the bases are the same, that means the exponents can be set as equal in order to then we could isolate T, which is in your exponent. So again, these are sort of tricky things. Go back to lesson 8 if you need a refresher on those specifically. Then in lesson 9, we looked at loans and RSPs. So loans are when you borrow money that is to be paid back through equal payments over a set period of time, including the interest. The payments are calculated according to how much you want to borrow, or how much we can borrow is calculated according to the payment we can afford. So this is sort of gives you a couple of options. Then we also looked at RSPs and that they are saving plans for people who earn an income and pay into it. And then it pays regular payments once you retire so that you continue to have that biweekly or monthly income so that you are able to survive. And ideally, investing early sets you up for the most success in the long run. So giving your money a long time to compound and to grow is going to set you up for the most success. There are quite a few formulas from this lesson, and there's a few places in the video that are really good places to screenshot or to capture so that you can figure out which formula you use in which situation. Then we looked at lesson 10, which was buying new and used vehicles and the costs of owning a vehicle. So when we looked at buying a new vehicle, we figured out how to calculate a monthly payment, which was the same as when we were looking at loans from the previous lesson. And then we learned how to complete a deal review and all of the elements that are involved in when you're buying a new vehicle, all the various charges and fees that are wrapped into that. Then we talked about buying a used vehicle. Specifically, we looked at calculating the depreciation value, which is how much a vehicle is worth after a certain period of time. So all vehicles lose value quite quickly, but some of them lose value at a faster rate than others. And then we talked about the cost of owning a vehicle. So we looked at calculating fuel costs and calculating monthly cost averages so that you could budget. So looking at fuel, maintenance, insurance, licensing fees, things like that, so that you can really be planning well for your expenses. Then this week we started with lesson 11, looking at trigonometry ratios. So first we looked at the primary trigonometry ratios, which are sine, cosine, and tangent. And we learned that labeling the right angle triangle is essential. So these primary trigonometric ratios are only when you are looking at a right angle triangle. And then you can figure out the reference angle and the opposite, adjacent, and hypotenuse sides according to that reference angle. Some folks use the phrase SOHCAHTOA to help remember how these ratios work, but I also just like to write them all out. So reminding you that sine of A, your reference angle, is equal to opposite over hypotenuse. Your cos of A is equal to adjacent over hypotenuse, and your tan of A is equal to opposite over adjacent. Then we figured out how to use that information to solve for an unknown side, and then also how to solve for an unknown angle, specifically using the inverse function, which is a button on your calculator that you need to know how to use. Oh, and finally, anytime that we're talking about trigonometry, so in lesson 11, 12, 13, and then 14, your calculator must be degrees. Generally, your calculator usually is always in degrees and it doesn't have an impact on anything else. But when you are doing trigonometry and you're using the sine, cosine, and tan buttons, then your calculator must be in degrees, or else you will get answers that seem really, really odd because they're different units of measure, which we are not learning about. And then finally, we looked at lesson 12, which is the sine law. So here we learned about labeling triangles and how the vertices are labeled with capital letters and the sides are labeled with lowercase letters, and they correspond to each other. They match each other opposites. So if a corner is R, capital R, then the corresponding side directly across that the vertice is not touching, that is going to be side small r. So then we talked about how you can know when to use the sine law, when is this a useful tool. So first off, the sine law does apply. You can use the sine law when you have right angle triangles, though using primary trigonometry is going to be generally easier, but you can do that. However, the sine law is most beneficial when you do not have a right angle triangle, so you cannot use primary trigonometry. So the situations where you can use the sine law are when you know two of your angles and one side. Part of that is because you can always figure out your third angle if you know two angles. Or you know two sides and an angle that is opposite one of the sides. So if you only know one angle, it has to be opposite one of the sides in order to use the sine law. So then we talked about how there are two different versions of the same formula of the sine law, but both work in all situations. Really just using one or the other is to make your life easy and make it so you don't have to do as much algebra, but you should get the same answer either way if you're doing everything correctly. If you want to use the two different versions, the sine law for angles, that's easier for finding angles, is sine A over small a equals sine B over small b equals sine C over small c. So where the angles are situated on the top makes it easier to find. If we're looking for sides, then doing the inverse, doing the flip of that is going to make it easier to find for sides. So small a divided by sine A is equal to small b divided by sine B is equal to small c divided by sine C. All right, and that is what we have covered so far this term. So we've done a lot. There's only 20 lessons and we've now completed 12. So that means we've got 8 lessons to go. So we've come a long way. So let's do some mixed practice to really make sure that we're able to figure out what tools we need to use when we have various questions. All right, number 1. A ladder is resting against a tree. The foot of the ladder is 2 meters from the base of the tree. The ladder forms an 48-degree angle with the ground, how far up the tree does the ladder reach to the nearest 1/10 of a meter? I feel like we did this one already, possibly in our, but whatever, we'll do it again in case we didn't do it. So if you, in this situation, if you don't have a diagram, you can draw yourself diagram. Your diagram does not need to be beautiful. So there I have my ladder. My ladder is 2 meters from the base of the tree. Whenever we have something coming out of the ground, we always assume that that is a 90-degree angle because things generally grow directly up and we generally build things so they are not leaning so that we can, yes, so that things are stable. So the ladder forms an angle of 48 degrees. My pen has stopped working. So it has formed an angle of 48 degrees with the ground. And we are looking for the height of the tree. So I'm going to call the height of the tree T. So here my reference angle is this 48 degrees. So across from my reference angle is the opposite, which is the T side, and the adjacent is the 2 meter side. So because I have opposite and adjacent, that means I'm going to be using tan. So tan of 48 is equal to opposite over adjacent. So tan of 48 is equal to T over 2. So then I'm going to multiply both sides by 2 so that they cancel off on this one side and we're isolating for T. So then we have 2 times tan 48. So we're going to use our Desmos calculator. Oops, except that I don't want it there. Gives us 2.22. So height of the tree is 2.22 meters. And writing a sentence means that we know we've answered the question. We don't have more steps to do. Okay, so that's a primary trig question. Number 2, a flare is sent up at a distress signal. The path is modeled by the relation h equals -4.9 times t minus 6 squared plus 177.4. What is the flare's height? How long will it take for the flare to reach the maximum height? So this is going to be, because we have a quadratic equation here, we know that it's going to be a quadratic question. Sorry, my pen and my calculator really, technology hates me. So to figure out how long the flare will take to reach the maximum height is we want to figure out where that is happening. So if I draw a rough sketch of this, so I'm going to look at my A is equal to -4.9. So that means that it's going to be opening down. And it's going to be narrow. Then H is equal to +6. So shift right 6. And K is equal to 177.4, which is a shift up 177.4. And this we're talking about our vertice, right? So when we're shifting, we're starting with our vertices. So in our basic parabola, looks something like that. So our flare, we're going to shift to the right 6. So that's going to be somewhere like this. And then we're going to shift up 177.4. Now, again, this doesn't have to be perfect. And then we know we're opening down and we're going pretty fast. So we go up pretty high and then come down pretty high. So if we look at this, we can see, well, our maximum height happens here at our vertex. And that happens after 6 seconds. So therefore, the maximum height happens after 6 seconds. And the max height is, how high does it go? Well, it goes all the way up to 177.4 meters. There we go. We've answered those questions. Part B, typically a flare will stay lit for 7 seconds. What will the height of the flare be at 7 seconds after it is launched? So we're trying to figure out, my drawing went away. We know that it looks something like this. It's all good if it's not perfect. So we're looking at 7 seconds. How high will it be when it goes out? So we can roughly guesstimate by looking at our graph, but we don't want to do that. We want to actually solve for it. So if the height is 7, now we want to figure out what the time is going to be. So we're going to substitute this into our formula. To solve for t. So we're going to put 7 into our formula. So we have 7 equals negative 4.9 times t, take away 6 squared plus 177.4. And now we're going to try to isolate for t. That's what our goal is. So we're going to subtract 177.4 from each side. So that means we don't have it on the side with the t anymore. So if we subtract that, 7 take away 177.4 is equal to negative 170.4. Then we're going to divide both sides by negative 4.9. And this is algebra, which hopefully is something you are familiar with. So you're going to do that on our calculator. So negative 170.4 divided by negative 4.9 is equal to 34.8. Now we need to get rid of the squared. So we're going to take the square root of the one side, which makes we take the square root from the other side. So we take the square root of 34.8. We end up with, so we actually end up with, this just is giving us a positive answer, but we end up with both a positive and a negative of 5.89, so 5.9 equals t minus 6. So that means that either 5.9 minus 6 equals t, or 5.9 plus 6, no, negative 5.9 plus 6 equals t. So either 5.9 plus 6 equals t, so that would be that t is equal to 11.9 in height, or negative 5.9 plus 6 equals t, which is 0.1 meters. So that's because we reach this height early. We reach this height at I totally just did that wrong completely. I solved for height of 7 opposed to 7 seconds. So yay for me. So I'm sorry. Oh goodness. So ignore all that. That is all correct if we were looking for height of 7. And so we're looking for what time do we hit a height of 7 seconds. So either at 0.1 second, we reach a height of 7 meters, or at 11.9 seconds, we reach a height of 7 meters. But what the question was asking was, how high were we when we are at 7 seconds? So that is t equals 7 seconds. So we are trying to figure out h. So we just have to substitute it in. I again apologize, but teachers make mistakes too. So we just substituted in 7 for our t, which means that we have negative 4.9 times 1 squared plus 177.4. So we have negative 4.9 plus 177.4, which is equal to 172.5. So the flare goes out at 172.5 meters high. Okay, sorry about that. Question C, after how many seconds will the flare hit the water? So this would be solving for h is equal to 0, and then doing all of those steps that I did for h is equal to 7 to find out when the flare hits the water. I'm not going to do that, seeing how I just did it all for the wrong h, but just for the sake of time and moving on to another topic, we are not going to do that right now. I apologize for my mistake. If you have any questions, feel free to reach out. All right, number 3, your car's fuel consumption rate is 12.2 liters per 100 kilometers, and your gas cost is 1.65 liters in Ontario and $1.50 per liter in Manitoba. It is 290 kilometers from Sioux Lookout to the Ontario-Manitoba border. Does it cost more to drive from Sioux Lookout to Winnipeg, which is 448 kilometers from Sioux Lookout, or to Thunder Bay, which is 392 kilometers from Sioux Lookout? So this, we're sort of assuming that we are paying for gas. It's like we're gonna run out of gas immediately once we hit the Manitoba border and have to fuel up there, which isn't realistic, but that's what we're gonna imagine it's gonna be to figure out this question. So this is a fuel consumption question, or a vehicle costs. So first, if we went to Winnipeg, we would have 2 parts of the trip. We have from Sioux Lookout to the border, and then from the border to Winnipeg. So we need to figure out how many kilometers are in each of these sections. So from Sioux Lookout to the border, that is going to be 448. Oh no, we already know what that is. It is 290. So to figure out how many are left to go to Winnipeg, 448 take away 290, and I'm going to use my calculator because I just keep screwing things up, is 158. So it's 158 kilometers to go there. So then to figure out how much it costs, we first need to figure out how much fuel is consumed. So to drive from Sioux Lookout to the border for 290 kilometers, at a fuel rate consumption of 2.2 liters per 100 kilometers. So we multiply that by 290, which is equal to 12.2 divided by 100 times 290. Is equal to 35.38. So we use 35.38 liters to go to the border, to go to Winnipeg. It's 12.2 divided by 100 times 158, because we're driving 158 kilometers in Manitoba. So we do 12.29 divided by 100 times 158. So we have 19.28 liters in Manitoba. So then to figure out the cost, it's going to be 35.38 liters times the cost of gas in Ontario, which is $1.65 per liter, plus 19.28 liters times $1.50, which is how much it costs in Manitoba. So add those together. And we get I feel like I've done something wrong. Yes, I did not have a decimal point there. So I got an answer of 2,950, which I'm like, that is too much money. That does not cost me $3,000 to drive to Manitoba for gas. I missed a decimal point. So that is why my number was so high. So always, if you get an answer from your calculator that does not make sense, check. Just try it again. Don't trust your calculator. So we end up with having to pay $87.30 to drive to Winnipeg in gas. So if we are going to Thunder Bay, then we are driving 392 kilometers. So first, to figure out how much fuel we used, we do 12.2 liters per 100 kilometers times 392, which is equal to 392 is equal to 47.82 liters. So then the cost is 47.82 times $1.65 for the cost of gas in Ontario, which is pretty close to actually what it is right now. It's actually lower than that, which when we started the course, it wasn't, which costs us $78.90. So it is cheaper to drive to Thunder Bay. There we go, because you don't use as much gas. All right, number 4, how much will Kalen owe on his overdue credit card balance of $652 if interest is compounded daily for 25 days at 18.5% annual interest? So this says compounded, so we know this is going to be a compound interest question. So I'm going to think about what my formula is. A equals P times 1 plus R over N to the exponent NT, so that I know all of my variables that I need to figure out. So A is what I'm trying to figure out, how much you will owe. P is 652. That's how much my balance is. R is 18.5%. So that is 0.185. N is compounded daily, so 365. And T is 25 out of 365 because it is a day. So I need to figure out how much that is in relation to years. I'm going to leave it in fraction just to get a more accurate answer. So now I'm going to fill in all of my numbers. So I have 652 times 1 plus 0.185 divided by 365, all to the exponent of 365 times 25 divided by 365. All right, so if we go into our calculator, I like to put it all in one go. And then it's easier for me to figure out where I made mistakes if I've made mistakes. If that's not for you, no worries, you do you. So put that all in, and remember, you have to figure out how your calculator best does things. So $660.31. So Kaylin will owe $660.31 if he does not pay that, if he carries that balance for 25 days. All right, number 5, a fox population is declining by 1.8% per year. The population can be modeled by using the formula P equals 210 times 0.982 to the exponent n, where P is a population after n years. Use technology to graph this relation. So I have done this ahead of time. I use Desmos, and to use Desmos, what I did is I put in P equals 210 times 0.982 to the exponent n, and then I went to the settings and changed my scale so that I got it in a way that looked nice so I could look at information. So then part B, what is the current fox population? So because the way that this is framed, we're at year 0. So we're at the beginning. So right now, how many foxes do we have? Well, we currently have 210 foxes. What is the expected fox population in 8 years? So I'm going to look at my time. So my time is down here, and this is my population. Sorry, I should have labeled that. It's always good to label your axes when you're doing a graph. I apologize for not doing that. My bad. I'm going to look at when 8 years is. So 8 years is here. So I'm going to follow this line up and look to see, okay, here, approximately here, which is about, well, this is 150, 160, 170, 180. So it's approximately 180 foxes is what the population will be expected in 8 years. And D, what will the fox population be when will the fox population be half the current population? So the current population is 210. So half the current population would be 105. So I'm trying to figure out when would it be 105? Ideally, I would have some sort of straight edge, which I don't, but I'm going to use this book that I've reached for. You can see that my line is not perfectly straight. So this is why reading off of a graph isn't always great. But then we can see that, and if we did it with actually the equation, we would get a more precise example or answer, but it will be approximately in 35, 36, 37, 38 years, the population will be half of what it currently is for foxes. And that is solving exponential questions. A communication tower is built on the slope of a hill. A surveyor 50 meters uphill from the base of the tower measures an angle of 50 degrees between the ground and the top of the tower. The angle from the top of the tower to the surveyor is 60 degrees. Calculate the height of the tower to the nearest meter. Okay, so we have a tower. We're going to draw ourselves a picture. It's going to be beautiful. We have a tower. And then we have a surveyor who is up a hill. And this distance is 50 meters. And looking at the tower, sorry, was the top of the tower? Yes, looking to the top of the tower. And this angle is 50 degrees. The angle between, nope, I did that wrong. Measuring, so the angle between the ground and the tower, what? No, survey uphill, measure an angle between the ground, top of the tower. I was right, that is have to be 50 degrees. The angle from the top of the tower to the surveyor. So for this angle, no. This angle here is 60 degrees. So this is why drawing yourself a picture, even though it looks completely ridiculous, is really good, because you get, if you're getting things mixed up, it's easier to figure out. Calculate the height of the tower to the nearest meter. So I've erased the rest of my picture and I'm left with a squiggly line triangle, but that's just because I drew squiggly lines. So we're going to imagine that this is a, these are straight line triangles. So we have two angles and sides that are opposite each other, so we can use the sine law. I'm just going to label my corners so that I have some letters. So I want a sine to find a side, so I'm actually going to put that on top. So sine B of B is equal to A over sine A. So B, I'm actually calling T for tower, of sine 50 is equal to 50 over sine 60. So T is equal to 50 times sine 60, sorry, 50 times sine 50 over sine 60. It can be tricky when the numbers are so similar. Using our calculator, we have 50 times sine 50 divided by sine 60 is equal to 44.2, so 44 meters. Therefore, the tower is 44 meters tall. And that is a sine law question. All right, so we don't have time to do this last question, but you are now, we've reviewed lessons 1 through 12. So you're able to hand these in for marking if you would like. You do not need to do them all. Do what you have done and then hand it in. Show all of your work. If you have any questions, please feel free to connect with me. This is why I'm here, to support you. Give me a call at 807-737-1488, extension 2209. Call or toll free 1-800-667-3703. Send me an email at bronwyn.slate@nnec.on.ca or a Facebook message at bslatewasa. Remember, this lesson and all of our previous lessons are up on YouTube, where my channel is called bslatewasa under a playlist called MBF3C. Thank you so much for joining me today. Miigwech.